Okay, welcome back everybody. Our final speaker today for the second online Gregory G. Leptoukh Giovanni workshop will be the workshop organizer, Dr. James Acker. It is my pleasure to reintroduce him. He is also a senior support scientist at the NASA Goddard Earth Sciences Data and Information Services Center, also referred to as the guest disk or the Goddard DAC. Jim?
Okay, hello. Just waiting for the presentation to load up. Unlike the people that I invited to the workshop where I had found their presentations, found papers published in journals, this particular presentation is based on something that happened very recently, back in August. And I was able to indulge my own interest in it by making a presentation on it. I think I found some interesting things that I may discuss with some of the other people that are involved with this type of study. Anyways, so the title is The Characterization of Environmental Factors Before and During the Lake Erie Toxic Phytoplankton Bloom in August of 2014. So, to put the event in context, if you hadn't heard of it, in late July and early August of 2014, a bloom of microcystis caused a do not drink order for the city of Toledo, Ohio on August 2nd and 3rd. And microcystis is a toxic, blue-green algae that produces a neurotoxin called microcystin. The bloom was small, but it was concentrated right at the location of the Toledo water intake crib. And the Google map below shows you both where the city of Toledo is, right here, and the location of the water crib. And I have some pictures of that coming up. And so this presentation examines several data sets available in Giovanni to evaluate the environmental precursors and see if there was anything out of the ordinary that would make this one worse than the normal blooms in Lake Erie, which have, over the last couple of years, re-intensified after a period where they thought they were getting better. Quick note about microcystin: it's not necessarily fatal. It can cause distress in various forms, and one of the main concerns is pets, like drinking raw water. But when it's high enough concentrations, they don't want humans to consume it. That's why they had to shut down the drinking water system. So this shows a couple of pictures taken around the time that were found in the media, and this shows the microcystis bloom around the Toledo water intake. They call this a crib. It basically is a concrete structure that the water is taken from below the surface and pumped to the water processing plant on shore, and then pumped out to the water distribution system for the city. Here's a picture, microphotograph of microcystis. It's a small algae, and actually to figure out if it's a concern, they put it under a microscope and look for these little clusters that you can see right here. And then this is someone who pulled out a water sample next to the crib when it was going on, and showing, it's probably not all microcystis, there are probably other things growing in there too, but you can see that it was a very, very green sample of water. Okay, and here's a MODIS image of the bloom. Shows what you could see with the real color view of it. So we're going to be looking at this area in subsequent analyses. And this is the area of western Lake Erie. It's shallow. It's somewhat confined due to the island systems in this peninsula here. So when these blooms take off, they can grow quite strongly here. And unfortunately, that's where the water intake is located. The main water source for the area is the Maumee River, and you can see the Maumee River watershed is here, and this is the one they're concerned about, the main source of nutrients. It's highly agricultural. You can see that parts of the watershed are in Michigan, Indiana, and Ohio. So the first thing that I looked at in our system was some of the various ocean color data products that we have, and primary among them is what you're looking at, phytoplankton, is chlorophyll. One of the things we'll see is that because this is level 3 data that is quality controlled, we don't see a lot of the really high concentrations. Anyways, we are looking at chlorophyll A concentration here, and the brightness of the bloom was such that probably in the processing that it was flagged for a number of optical conditions. Really bright areas can be interpreted as land. They call that a land flag. There's other conditions where the the basic atmospheric correction of the data doesn't work properly, and they flag that for a failure of the atmospheric correction algorithm. All of these things can happen when you have bright waters. So in the rightmost image here, you can see some high concentrations located near the area of the bloom. If you remember the MODIS image I showed, the bloom was basically highest in this area. And the star shows about where Toledo is located. So I'm looking at euphotic depth here, and euphotic depth is an indication of water turbidity, and we're going to get about the same distribution of available pixels with each data product. So you can see that the euphotic depth is indicating about a 2 meter or so penetration where it was thickest, and obviously saw the pictures. You can see that it was a fairly dense bloom, which meant that the light attenuation was fairly strong due to the amount of algae. And this is a product called normalized fluorescence line height, which indicates where bacteria are actively growing. What's interesting when I look at this on the edges of the bloom, essentially before it happened, as you can see, the NFLH was here, was high, showing where it was growing, also out in the main body of the lake. But you don't see the growth as much here on the edge. It's a lower value, which I find interesting. May have meant that the bloom had essentially started to actually stagnate and not be the growth. And one thing that can happen with some of these really thick blooms is that they can self-regulate because so little light is getting lower down in the water column when they're so thick. And so there may not have been as much growth as when it was in the cursory period when it was getting started. And finally, this is the absorption coefficient for phytoplankton, just to see if we have phytoplankton out there. You can see prior to the bloom, the bloom in the area by the crib, you can see there was some over to the east of the area, and then again we can see this area right on the edge showing that it was phytoplankton absorption. Now, the NOAA has an actual forecast system for cyanobacteria, and I presume, though I have not investigated how they actually do it, that they use level 2 data and process it themselves, because they can see where the level 3 data was not showing data. Okay, and so they actually put out a report once a week, though when this bloom occurred, they actually started putting it out experimentally twice a week. Okay, and so when they looked at the August 3rd imagery, they said that the microcystis bloom has intensified since last Thursday, and the area covered by medium to high concentrations, green to red, has increased. Calm winds have allowed the bloom to concentrate near the surface. Patches of scum were present in the areas of high concentration. So what's interesting is that in the period before that, they basically didn't say much was happening. They didn't even predict that they would see this big explosion. So on the 24th, here and even on the 31st, there wasn't any real alarm bells sounded that it would turn into this massive eruption, essentially, of bacteria. I'm sorry, of plankton that caused the drinking water alert. So now what I'm going to do is I'm going to look at a number of different time series of variables that could potentially be related to the development of this bloom in Lake Erie. Now, the first one is sea surface temperature. And I had earlier asked Dr. Roy about whether or not there was an association with picoplankton and sea surface temperature in his work, because in research, the quick research I did on microcystis, the indications are that microcystis, which is variously called a blue-green algae or a cyanobacteria, really do thrive in warm water. And there was a particular note that said temperatures above 25 degrees centigrade are very favorable for microcystis growth. Now, we do not yet have a high-resolution sea surface temperature product either spatially or temporally. And so we do have a sea surface temperature product from MODIS. And so I looked at it from the period 2003 to 2014, and you can see peak summer temperatures get over that 25-degree threshold, which I designated with the black line. Now, what's interesting is that this was the most recent month of July that I could get in the data, and it doesn't quite reach that threshold, but the difference is fairly insignificant. It's probably 24.5 degrees. So, and this was averaged over the entire month. That's why high-resolution data would be useful to see if it actually got warmer late in the month, which I suspect looking at the other data sets. And note that the 11 micron band, and this was data acquired during the daytime, so the nighttime band would have been slightly cooler. Okay, now this is an air surface temperature product that comes out from the North American Land Data Assimilation System, which we call NLDAS. And this actually is quite interesting because it's available on an hourly basis. And so I looked at this, and fairly short term, you can see this is July 25th. The dotted black line right here designate August 1st. So if you remember, the drinking water alert was on August 2nd and 3rd. So you can definitely see the diurnal, definitely see the diurnal cycle of temperatures cooling off a bit and then warming up. And we can see that temperatures in the daytime progressively increased, this being the second. And so it was getting warmer, again making me suspect that the surface temperature of the lake water was also increasing. Now, I also looked at cloud fraction, which is available from both MODIS and Aqua, and I made time series for this period starting, this is the beginning of July, going through the end of August, for both MODIS Aqua and for MODIS Terra. I didn't see as much in MODIS Terra, or I also looked at the nighttime. There's a number of different options. There's a day only, night only, and a day and night. And this was the most indicative and unusual of all of them, and I found it very significant because MODIS Aqua is in an orbit that crosses in the afternoon. The reason it was called Aqua is that it was orbited in that particular time so that the buildup of clouds, essentially the hydrologic cycle, could be seen. The MODIS Terra, which is designed to look at the land, orbits where it crosses the equator, or approximately local time about 10:30 in the morning, so that it crosses before clouds start to build up, so you get a better view of the land surface. So Aqua in the day is looking at this warming that occurs because of solar heating and the buildup of clouds. And so what we see here was, as we approached the period of the bloom, August 2nd and 3rd, where they shut down the water system again, was that the cloud fraction from Aqua, which is this afternoon period when the clouds should be building up, dropped significantly. You can see it drop down to a minima here. It got, very later in the month, it goes lower. But this was right before the period of the bloom. So this makes me suspect that it was very cloudless, quite warm because it was summer. We could see the temperatures going up. And this means that the photosynthetically available radiation that the chlorophyll and anything with chlorophyll in it uses to grow was available at a high level. And so I found this was the most unusual thing that I saw in all of the data sets that I looked at that wasn't mentioned by anyone else. Okay. Now, it was mentioned that wind speeds were calm, and this is quite evident. Now, this is looking at data from the NLDAS as well, and I'm looking at the period July 15th, August 15th, and then I look closer, July 30th, August 3rd. I'm looking at both the zonal winds and the meridional winds. So this is the meridional winds here, this is the zonal winds here. You can see there was some stronger wind events prior to this period, but right as we get to August 1st, this is the line, winds became light. You can even see that even more so when I zoom in on just the period around the time of the event, that they dropped down, the meridional winds dropped down to below 2 meters per second. zonal winds, you can also see they were high. They did differ in direction, but as we get to the period of the bloom, they dropped down, and there was a period of quiescence, essentially, both as the bloom took place. So during this period, you get less wind. That means there's less movement of the bloom. They can concentrate, and there's also stratification, putting nutrients near the surface, and basically building up the growth environment. So this was the perfect storm for microcystis. Both growth conditions were good, and dispersal of the bloom was not favored. So it basically hung around the water crib, and this was what caused the crisis. Okay, now what was interesting about this, and this is also mentioned in some of the articles, was that they do know that in years when the runoff from the Maumee River watershed is high, that you are getting a larger nutrient contribution to the lake, especially at this area in the western lake. And this is when you would expect to see more microcystis activity. Okay, and what was interesting about this was, it was noted in one of the articles, was that there was the subsurface, the runoff was high, and yet they didn't actually see a precipitation. Precipitation was actually light. Now, the prior weather was extremely cold winter, so it's possible that there was some storage underground, that it was more soil moisture, so that the runoff was maintained at a higher level than you would expect from a lower rain, warm summer. Okay, so this is looking at the period from 2002 to 2014. So 2014 is here, and this is looking at just 2010 to 2014. I've noted both May and December 2011.
Hello, you have been conducting a meeting for a long period of time. If you need to continue meeting, press 1 now. If not, I'll end the meeting.
Subsurface runoff, May 2014, a couple of months before the summer. Now we're looking at the period, we're looking at surface runoff rather than subsurface runoff. This is using the NOAA model. There's a couple of different models included in NLDAS. And so you can see that prior to the 2012 bloom, runoff was high in February 2011 and dropped off. It was high a little bit later in the period, in March and April, before the bloom in 2014. Okay, looking at one other model, we're looking at the mosaic model, a little bit different. This one shows a peak in March and a drop off, so it doesn't show that same peak in April that the other model showed, but still a very high peak in March. You can see that a couple other months were high. This is actually February. This is probably February of 2011 peak. So I'm sorry, that's February of 2008. So this was a significant amount of runoff during the period. So both the NOAA and the mosaic model show that there was increased surface runoff in the spring, and as it was noted that the surface runoff in 2014 was somewhat unusual because there wasn't as much rain. Okay. So in summary, the level 3 ocean color data products that we have indicated the presence of the cyanobacterial bloom that occurred in Lake Erie in July-August 2014 and caused the drinking water crisis. The sea surface temperatures for the lake indicate that it was favorable temperature for microcystis. It would be useful to have higher temporal resolution data, which our Federated Giovanni product is expected to bring in. We can see that the air surface temperature was increasing both before and during the bloom. The daytime afternoon cloud fraction substantially decreased in the days directly preceding the bloom, which I think is probably the most interesting precursory data that I saw. The wind speeds were light before the bloom, which caused the bloom waters to remain stationary. This was a situation conducive to stratification, which could concentrate the bloom in the surface waters and augment the growth. It's known that high subsurface and surface runoff in the spring appears to prime the system with a large input of nutrients from agriculture that seem to be available, seem to be stored in the system with some latency. The October 2011 bloom occurred later than the July-August 2014 bloom, both of which seem to derive their sustenance from the nutrients that came in the spring. And so I would recommend that the current observational forecast effort, and this is, I know the individual that likely puts these out at NOAA, might potentially be augmented looking at cloud fraction data and PAR data. The question would be, is it available from our satellites and from our data systems with, what am I looking for? Is there a near real-time product that is sufficiently accurate to provide essentially forecast information? What they do with the system that NOAA puts out is they detect it using ocean color and then predict where it might be going. But they don't have a sense of predicting that it will do what it did this year, which is basically go from fairly benign to dangerous in a matter of a short period of time. And so we might have a way of doing that as well. I suspect that they do routine water quality testing and look at nutrient concentrations as another predictive element. Now, I'm not quite done, because subsequent to this episode, it had turned out that they were considering and seeking funding to put in a water quality buoy right next to the Toledo water crib. One of the interesting comments was that after the event took place, things settled down, people of Toledo were able to drink water out of their taps again, was that they basically walked the funding proposal to the office where it was immediately signed, and within approximately a week of the bloom, there was a water quality buoy sitting, as you can see, right next to the Toledo water crib. So next year, they will be a little better prepared. Okay, this points out that this has a total algae sensor, which measures both chlorophyll and phycocyanin. And phycocyanin is the pigment that the ocean color algorithm likely tries to detect, which is the pigment that is produced by the blue-green algae. Okay, so the plant operators will know before they, at least subsequent to getting the water in the system, that there may be a problem with the blue-green algae. It also points out it gets water temperature, conductivity, pH, oxidation reduction potential, and turbidity. Not sure what they use oxidation reduction potential for. Okay, they also have an acoustic instrument which can measure wave heights and water currents. So it can also tell you how quickly the water is going, and you can actually go to a camera and see pictures of the conditions at this particular buoy. Okay. The one thing I will point out, and I know that from working with the ocean color community, these instruments do exist and they're fairly good. They did not put a light sensor on it where they can detect daily PAR, they can detect daily solar irradiance, and that surprises me. And it's something that can actually, they could put another buoy out, right next to it with a sensor like that. But I think that would be additional useful information. Clearly, they could do this on shore. The crib is really only 3 miles offshore, so you don't expect your conditions to be too much different when you're that close to the shore. But I think that would be something that would augment their effort to monitor water conditions and hopefully take care of them. One thing of interest that just occurred, didn't even have a chance to put it into my presentation, was an article just came out that says Lake Erie is becoming more sensitive to the occurrence of these large blooms. So you can investigate on the internet. You can search Lake Erie sensitivity bloom, something like that, and you can read that article. So I didn't have a question finishing slide. That's all I have. And for those listening, I want to thank everyone that took part. And so I can take questions. I'll also point out we're going to have a little, right at the end, if you're still online, you can also take part in a few polling questions that we'll make available where you can answer some questions about the workshop. Thank you.
All right, thank you, Jim. All right, so what we'll do next is we will move to the question and answer period for Dr. Acker's talk. You can see here I've got his file in the file sharing pod in the lower right-hand corner of your screen. Again, you select the file. That will provide you an opportunity to download that file. After the question and answer period, I would like to move, there's 4 polling questions. I realize this is just a subset of the, all of the participants, but I think your input would be very important. And of course, those questions are optional, but we certainly would appreciate your feedback. We'll probably take like 10 minutes or so for those. And then at the end of that, we'll move to the slide where I have all of the presentations uploaded for your viewing and downloading pleasure. I will leave the room open at that point for about 15 minutes or so for those of you interested in downloading. As I said, I will upload Dr. Singh's recording to accompany his presentation. I hope to have that completed by tomorrow, as we were unable to hear his talk during his scheduled time slot. All right, so let's move now to questions for Dr. Acker. The first question, Jim, is, you said that level 2 data could be used to have a better picture. However, level 2 data of chlorophyll A can't avoid cloud cover. Do you think that in the future satellites could measure even with cloud cover?
That's a good question. The normal way that cloud cover is dealt with ocean color, which ocean color being visible radiometric data is subject to clouds. A comment from when the early days of CWIS was, wow, the world is a very cloudy place. No, there isn't any type of data that there isn't any type of sensor that could actually get data in the visible range from the surface. There is the AVHRR, the sea surface temperature, has some capability of seeing through clouds, and actually some of the microwave sensors on that do precipitation radar, some of those on the TRIM satellite, I think GPM, can actually see surface temperature when it's very cloudy. So there would be the potential to see surface temperature, but not ocean color. Most of the time, the cloudier, the less cloud images that you see for ocean color are averaged over a period of either 8 days or a month. We aren't even going to put daily data into Giovanni because the amount of clouds usually makes the statistical process inaccurate if it's not done with the protocols that the Ocean Biology Processing Group uses to process it.
Okay, thank you, Jim. Our next question is there lake monitoring data available that support the idea of nutrients being available following the spring loadings?
Based on my reading, I assume that there is. The person that does the HAB forecasts is a man named Rick Stump, because I've known of him for many years, various things that he's done with ocean color data, and there is an article talking about his look at this particular event. And he was the one that discussed the fact that they looked at the loading and the runoff conditions in the spring, which lead to the essentially the system being ready for blooms like this. So he's very aware of this, and that the article was this was the article that indicated they couldn't quite figure out why the runoff stayed high when the rain in the spring was actually lower than normal. So I didn't consult any at this point. I'm actually thinking of seeing what Dr. Stump might be doing right now and saying, hey, I've got these data sets as well, and I wonder if that might be something that we could look at potentially in a report mode or even a publication. So I'd be very interested too, because you would assume that the spring blooms would use it up. It would use up most of the nutrients. Of course, the river's always flowing, so I think that's a good question.
Okay, thank you, Dr. Acker. The next question is, did the cloud fraction and winds increase later in the month, and did the blooms start to dissipate?
Yeah, it did. It did. Even in the couple of days right following the third, they were able to. It was so high just on the second and the third that was when they called in the alert and the drinking water ban. What was interesting was that they expected the bloom and the organisms, the plankton, to actually drift eastward and get into the main body of the lake and keep growing. You get into or open water, that there's more nutrients there than in the concentrated basin. I don't know if that happened. I mean, it didn't cause a drinking water crisis like the event at the beginning of August. Yeah, so it didn't remain in the one place for long where it made the situation worse for longer.
Okay, thank you, Jim. So the next question starts with a comment regarding this individual's research area of interest, and it's from Alejandro Dominguez. He is basically saying, I have an open question about Giovanni for the staff or people interested. He's writing from Mexico. Our particular case study is about time series of ocean currents and chemical properties in the Gulf of Mexico at different locations and depths from oceanographic buoys and moorings. We have large amounts of data and are curious how Giovanni can help us compare these series without having to handle or download large amounts of data.
I'll definitely take that. I'll recommend that Alejandro correspond with us, because we can give him more detailed instructions on how to use the data and the various ways that it can be accessed. We are in a process right now. We're doing what's called the Federated Giovanni Project. We are adding our data to Giovanni 4, and that process will take place over the next few months and should be available. It's currently in Giovanni 3rd. Excuse me, I was going to say Giovanni the 3rd, Giovanni 3, and can be used in the same way that I just did it. Yeah, we can definitely help out. There's various ways of getting the data in formats, and the nice thing about it is you can do time series, you can download the time series data, you can do maps. Most of our data is available at 8-day temporal resolution, which is pretty useful for things that go with the buoys and moorings. So we'd be glad to work with you.
Okay. Great. So I think, Alejandro, what I will do is I will pull your comment out of the question and answer and email Jim as a reminder with that specific comment so the two of you can converse offline, okay?
Absolutely. All
right, fantastic. The next question is from Shovanlal Roy, one of our earlier speakers today. Dr. Roy, as the progression of the cyanobacteria bloom, you mentioned could be seen as the progression of small cells, and do you think looking at the cell size from the time series can give indication of this bloom? If so, an absorption-based cell size model, which does not assume that high chlorophyll is due to large cells only, can probably be readily applied to find the possible relationship between the sea surface temperature / other variation and progression of this bloom.
Yeah, I think that's a very good idea. What I don't know enough about the bloom, because basically I learned about it from the readings, was that when they put it under the microscope, they're looking for the microcystis, which, as I understand it, shows up as little dark black clumps, which makes me believe that it's little dark black clumps in the midst of other algae that's growing there. So if it's not a monotypic bloom where you've got a variety, then you wouldn't be able to do this. But I don't know enough about it to know how monotypic the bloom might be. So that's something to be taken up. I think it would be great. I mean, I think it would be a really nice way of being able to help out the people looking at this problem, if something like that could be done, and if the temperature could really do it. I mean, I think the temperature is really a diagnostic in a lot of cases, because when it gets hot in July and August, that's when the blooms take off.
Okay, thank you, Jim. Our next question is, do you know of other big blooming events at other places and times where these analyses could be replicated?
Not for cyanobacteria, even though I know that cyanobacteria are a problem. The only other one that I know for sure that cyanobacteria have been designated as a problem is on the shores of the Baltic Sea, North Sea, Germany coast, Finland coast. It is a concern elsewhere, and so it's what's what I'm looking for? It is diagnostic to look for things like temperatures and things like that. Lake Erie is in a very unique situation with regards to this particular bloom, because the western basin is so enclosed, and these blooms can get very concentrated. And unfortunately, you can see where they put the water intake is just not in the not in the right place for a city the size of Toledo. And there's not much they can do about that except maybe make a big long pipeline to Lake Huron or something like that. So I think that the more useful thing is NOAA has the cyanobacterial index that they use the level 2 data where they're looking for the phycocyanin, that they could use that more readily than this. This was trying to see what in particular may have caused this bloom to be worse than prior years to where it caused the drinking water problem.
Okay, thank you, Jim. So this is more of a comment and a question for me. So there really are not any measures one can take to mitigate these type of events.
No.
Correct?
I mean,
naturally, you essentially need to wait it out. I mean, the only thing that, they've got going for them now is to be more prepared as far as looking at their measurements in advance.
Well, actually, the thing that could be done, and I think we have John Lerter on the line, it's something that we talked about with regards to the Mississippi River coastal hypoxia off the delta, is you have to somehow figure out a way to mitigate the nutrient input. And this frequently in areas, I mean, the Mississippi River and the Maumee River both are in the same situation as draining large agricultural areas, as is the rivers that drain into the Chesapeake Bay. And so this is an urban problem. It's a developmental problem where you get all of this stuff basically washing into the bay. I find this interesting because I helped my daughter with an editorial analysis for school that was about the recent Maryland election where the governor-elect was decrying the so-called rain tax. And the rain tax was levied to control stormwater runoff, which is one of the other things that can wash into the bay and cause nutrient problems, similar to other big cities like Toledo or New Orleans or St. Louis, and that contribute to the various other watersheds. So that's where, in order to address this problem long term, it would be done. Now, Lake Erie is a problem. It's the shallowest of the Great Lakes. It's got the least water volume, and it's completely surrounded by farmland. So the problem isn't going to go away anytime soon, unless they really address it. It requires changes in farming practices and water retention and all types of things to actually get at the problem. And that's not something that changes. It's like changing the direction of a cruise ship. You got to turn a long time before you see anything happen.
Okay, thank you, Jim.
Sure.
Any additional questions for our speaker?
Yeah, you can introduce the poll questions now too if you want to.
Sure.
Show those. So.
Sure. So here, yes, okay. And for the short answer questions, there's an icon directly to the right, and you click Submit after you've entered your responses.
We should put the same questions out by email to the people we have email addresses for.
Sure, if you would like that.
I think that'd be a great idea, actually. The first day where we had the Giovanni 4 interest, like the fourth question would probably be of interest to several of them.
Okay.
Yeah, I want to thank John Lerter for his email comment. I think we can further discuss that with here and with the OBPG as well too, because there are PAR products. There's a couple of different PAR products that are available.
So the other comment is people are answering the polling questions, and we can certainly go back to the question and answer in a minute if we need to. But I do have, every month I host a data discovery or data access webinar that is different from this particular workshop in that it normally will either focus on a category of data products. For example, we had a special 2-day webinar in May 2013 that focused on the GRIST sea surface temperature data products distributed through our NASA Physical Oceanography DAC. We have held several data discovery tool type of webinars for accessing ASTER or MODIS data, subsetting tools, a really large variety of workshops, including a Giovanni workshop that Jim Acker was, for which he was the speaker. I think that might have been also in 2013. And you can find that information on they're all posted there on our NASA Earth Data YouTube channel. If you type in, NASA Earth Data, all one word, and do a search on YouTube, you'll see our channel. We also have a Twitter account and a Facebook account, and if you're not already joined up or connecting with the Giovanni group, they have a Twitter account and a Goddard DAC Facebook account, right, Jim?
Right.
So keep those.
That's in my presentation from the first day.
Yes, and so keep all of that in mind. Those are ways to connect with us.
And while we're online, I want to make a plug for tomorrow's poster session, which the link is on the meeting page, and I will be putting the author email addresses. We're going to put them on so that they can't be grabbed by robots and turned into spam, so you'll actually have to convert the email address by writing it in a more standard format, but they will be available there. And some of them are very high quality. They were very interesting to look at, and some other data types that we haven't seen here in the talks too.
If there are additional comments or feedback that you have, you can feel free to either email Jim Acker, or you can email me as well, and I will ensure that he receives the feedback. What we will do now, I don't have any closing remarks.
No, I just want to thank everybody that is either listening or, I will thank everybody for participating. We had very high quality talks. I think I'm very glad that we did it this year verbally and with Adobe Connect so that we record them, and people that are actually asleep right now can come and see the talks subsequently at their times of their own choosing. So I'm very glad that we've done it. I think, again, it's not quite over. We have a poster session tomorrow, and just want to thank everybody for participating.
Go ahead and move to the final slide here, and I do have all of the presentations here for you. I will leave the room open for 15 minutes until 4 p.m. Eastern Standard Time for those of you who are interested in downloading. Again, no worries, this will still be here. It is a interactive pod that even with the recording, you will still be able to download after the fact. So, if you don't have an opportunity to download now, no worries, you'll be able to do so later as well. And I guess that's it. So thank you, everybody. I will be logging off from the telecon here unless Jim Acker has further comments.
No, we're good.
And